We are now ready to put all this information together to actually graph rational functions here in section 4.4.5. So let's jump right into example 4. Graph the following rational functions. Plot and label the vertical and horizontal asymptotes with the correct equations. Carefully plot and label the X and Y intercepts as ordered pairs. So let's go ahead and start from the beginning. The first thing we learned was the domain. So let's go ahead and find the domain of this function. Now remember, the domain occurs everywhere where the denominator is not 0. The 0 of this denominator is -2. Therefore, the domain is everything but -2. In interval notation, this would be from -infinity to -2 and -2 to infinity. So already we can begin to predict that the graph of this rational function will come in 2 branches. Remember, the 0 of the denominator is the restricted value of the domain, but it is the location of the vertical asymptote. So the equation of our vertical asymptote for this graph is x equals -2. I'm going to sketch this into the graph as a dashed line. Remember, this is not part of the graph. It's just a boundary line for the graph. So we have our domain. We have our vertical asymptote. Let's also find our horizontal asymptote. To find a horizontal asymptote, we have to observe the relative degrees of the numerator and the denominator. Now, start with the denominator. The degree of the denominator here is 1. What about the degree of the numerator? Can you recognize it? This would be degree 0. You could write that as 5 times x to the 0th power. So we're dealing with the case where the degree of the numerator is less than the degree of the denominator, or you could call this the Bobo case, right? Bigger on bottom 0. So the equation of our horizontal asymptote is y equals 0. We can sketch this into our graph with a dashed line. I like to use red because it's a boundary line. And the equation there is y equals 0. Next, we will find our X-Intercepts. Remember, the shortcut for finding the X-Intercept is to set the numerator equal to 0. But in this case, when we set the numerator equal to 0, we get a contradiction. So this means there is no X-intercept. And finally, to find our Y-intercept, we are going to set x equal to 0. So in this case, and remember our shortcut, we can find our ratio of constants here. So if we plug in a 0 for x, the only thing that's left are the constants. So the ordered pair location of our y-intercept is 0, 5/2. So it looks like we only have 1 point on our graph as a reference to construct the graph of this rational function. So those are the specifics. We can either plot points, that is, pick some x values and determine what comes out for y, or we can use our graphing calculator to sketch the general behavior of the graph. Make sure when you type this in that you put the denominator in a set of parentheses. And let me go ahead and do zoom 6. I had my viewing window changed previously. And at this point, I'm just looking at the general behavior of the graph. I've got the specifics constructed in the vertical and horizontal asymptotes. I've got my y-intercept. Next, I'm just, again, going to sketch the general behavior of the graph. So I want to show that the graph follows the asymptotes and is limited. It's not going to cross either one of them. And that's a pretty basic sketch of our rational function. Now, remember, our domain came in 2 pieces. The first piece was from -infinity to -2. That's describing the x values on this case. And from -2 to infinity. That's describing the x values on the right branch. So everything lines up and it verifies with our graphing calculator. That's not too bad. In my opinion, that's easier than graphing a polynomial function. Okay, let's go through that process again, starting with the domain. The domain is going to occur everywhere except where the denominator is 0. So I'm going to find the restricted values of the domain by setting the denominator equal to 0 and solving for x. Notice I solved that with the square root property. So the domain is going to be everything except -2 and +2. So in interval notation, the domain will be from -infinity to -2, union, -2 to 2, union 2 to infinity. So I can anticipate 3 branches for the graph of this rational function. Remember, the restricted values of the domain give the locations of the vertical asymptotes, and the equation of a vertical is x equal to a constant. So this function has 2 vertical asymptotes at -2 and 2. I'll go ahead and sketch those in as dashed lines on my graph, and I'm going to be careful to label them both with an equation. The next piece of information we should look for is the location of a horizontal asymptote. And remember, we examined the relative degrees of the top and the bottom. As we saw on the previous example, the degree of the top is 0 and the degree of the bottom is 2. So in this case, the degree of the numerator is less than the denominator. Again, that's our Bobo case, bigger on bottom. The equation of our horizontal asymptote then is y equals 0. So we can construct this horizontal asymptote right on top of the x-axis with equation y equals 0. Next, let's find our x and y intercepts. The shortcut for the x-intercept is to set the numerator equal to 0, but again, we get a contradiction as we did on example A, so our conclusion here is there are no x-intercepts. And the final piece of information that we need is a y-intercept, and we can do this also with a shortcut. We're going to find the ratio of constant terms, 1 over -4. So as an ordered pair, the location of our y-intercept is 0, -1/4. So about right there. Now, we don't have a whole lot of information in graphing our function. We're going to depend on our calculator for the rest, but if for some reason you didn't have your calculator, you could simply plot points. Choose some x values on either side of all of those vertical asymptotes, calculate the corresponding y values, and plot points. Our goal is to get the general behavior of the graph, so we will look at the pattern with our graphing calculator. So I'm going to type this in, 1 divided by x squared minus 4, being careful to get that x squared minus 4 in parentheses. And we have 3 clear pieces of the graph. So I'm going to sketch this onto my graph by hand, following the pattern seen on the calculator. Remember, the graph is going to be limited by those boundary lines. And also remember, our domain came in 3 pieces and our graph comes in 3 pieces. So everything is consistent and we can verify it in several ways. Let's look at one that's maybe a little more complicated. Let's begin with the domain. The domain is going to be everywhere except the zeros of the denominator. The zeros of the denominator in this case occur at 1 and -2. So when I express my domain in interval notation, I have to remember to get those in numerical order. So I'm going to go from -infinity to -2, union, -2 to 1, union 1 to infinity. So we are anticipating 3 branches to our graph. Now, the vertical asymptotes will occur at the restricted values of the denominator. The equation of a vertical asymptote is x equal to a constant. So in this case, we get x equals -2 and x equals 1. So I'm going to sketch in my vertical asymptotes. X equals -2 and x equals 1. The next piece of information we will look for is the equation of our horizontal asymptote. Now we do have to be a little bit careful here. Horizontal asymptotes are based on the degrees of the top and the bottom, and in both cases of the numerator and the denominator, our function is in factored form. So you don't have to FOIL everything out, but just to be very clear here, if I FOILed everything out, my function would look something like this. I can see that the degree of the top is equal to the degree of the bottom. That's that special case. So the equation of our horizontal asymptote is y equal to the ratio of leading coefficients. 1 divided by 1 is 1. So our equation then is y equals 1. And we can sketch that into our graph as a dashed boundary line with label y equals 1. Next, we will find our X-Intercepts. X-Intercepts have a shortcut. That is, we take our numerator and set it equal to 0. In this case, we're going to get 2 zeros in the numerator, 2 and -3. So officially, as ordered pairs, the X-intercepts would be 2, 0 and -3, 0. So I'm going to plot those on my graph. 2, 0 and -3, 0. Always nice to label those carefully with ordered pairs. And the last piece of information that we need is a Y-intercept. The shortcut for a Y-intercept is to find the ratio of constant terms. I can only do that if I have it in this multiplied out form. And -6 divided by -2 is +3. Again, if you want to go the traditional route and replace all the x's with zeros and calculate what's left, you'll end up with the same result. The y-intercept is 0, 3. So we can plot that on our graph. We are anticipating 3 branches to our graph, so we want to look for that. And be very careful how you type this in. If you didn't take the time to multiply this out and you want to type it in its original form, notice I'm going to put the numerator in a set of parentheses and the denominator in a set of parentheses. We always do that, but notice in this case it gives you a double open and a double close for both your numerator and denominator. So let's take a look at the graph. We're expecting 3 pieces or 3 branches, and we do in fact have 3 branches. So we're going to sketch that general behavior onto our sketch by hand. So this side is going to follow the asymptote here. Remember, this is an approximation. The specifics are the asymptotes and the intercepts. So there's a pretty good sketch of our rational function. Again, in some cases, easier than sketching a polynomial. Let's finish with one last problem, beginning with the domain of this function. Notice the restricted value in the denominator, that is the 0 of the denominator, is -3. So our domain will be -infinity to -3 and -3 to infinity. So as we begin to formulate the graph in our minds, this means our graph will have 2 branches. The equation of the vertical asymptote occurs at that restricted value, right? And the equation of a vertical asymptote is always x equal to whatever the constant is. For our horizontal asymptote, we're going to observe that the degree of the top is 1 and the degree of the bottom is 1. So I need to find those leading coefficients and form their ratio. So the equation of our horizontal asymptote is y equals 1. Now we can go ahead and sketch this information onto our graph as we go. And then we can proceed to X and Y intercepts. Remember our shortcut. The X-intercept comes from the 0 of the numerator. In this case, it's 5. So officially, as an ordered pair, our x-intercept is located at 5, 0. Thinking of the shortcut for our y-intercept, x is 0 and the y value is the ratio of the constants. So in this case, -5/3. So we can plot those 2 points onto our graph. Ordered pair 5, 0 and 0, -5/3. Let's think of -5/3 as -1 2/3. So we can imagine its location. And then we can use our graphing calculator to get the general behavior of the graph. So we'll type this in as x minus 5 enclosed in a set of parentheses divided by x plus 3 also enclosed in a set of parentheses. And we have a very basic graph that we will sketch. Now remember, we want to have the asymptotes correct, the y-intercepts correct, and then this part is a general sketch of the behavior of that graph. The domain had 2 intervals and our final graph has 2 branches, so everything lines up. All right, that's great news. That means you have completed Unit 4 notes and lectures. Once you complete your last set of homework, then you can proceed to the Unit 4 review, and best of luck to you on the Unit 4 exam.